Hey everyone, welcome back to my channel. My name is Priyanshi Agarwal and today I am here with a new topic, that is structure of the atom. So starting with Dalton's atomic theory, he proposed the atomic theory of matter based on his experimental observations. First, he recorded evidence that atoms existed. Dalton's theory was based on the premise that the atoms of different elements could be distinguished by differences in their weight. But the limitations were the indivisibility of an atom was proved wrong, for an atom can be further divided into protons, neutrons and electrons, and the atoms of same element are similar in all respects, but isotopes of same element have different mass. Starting with J.J. Thomson experiments, discovered electrons in 1897, showed us that atom can be split into even smaller parts. An atom is a uniform sphere of positive charge as well as negative charge. Atom as a whole is electrically neutral because the negative and positive charges are equal in magnitude. Now, very important thing, an electron is negatively charged component of an atom which exists outside the nucleus, means it revolves in the orbit. Each electron carries 1 unit of negative charge and has very small mass of compound with that of a neutron or proton. So the mass of an electron is very less than the mass of a neutron or electron. So what it is saying is that, like for an example, Cl, it is an ion with minus sign. So this minus represents the negative charge. This minus is actually the electrons present in that element. So you can see these blue colored dots are the negative electron, because these actually J.J. Thomson also had a plum pudding model. So in that he gave an example of a watermelon. He said watermelon में जो red part है that is proton, and the seeds in that watermelon seeds are just like electrons. So this is just like electrons in a watermelon. J. Thomson used cathode ray tubes to demonstrate that the cathode ray responds to both magnetic and electric fields. Since the ray was attached to a positive electric plate placed over the cathode ray tube, he determined that the ray must be composed of negatively charged particles, and he named those negative charged particles as electrons. But the limitations were, model failed to explain what was the arrangement of protons and electrons in an atom, means what were the arrangement where they were placed in an atom. Now comes GOLDSTEIN experiment. GOLDSTEIN in 1886 discovered the presence of new radiations in a gas discharge and called them canal rays. These rays were positively charged radiations, which ultimately led to the discovery of another subatomic particle, that is protons. Because it is seen that these rays are positively charged radiations, means protons. Used a cathode ray tube to study canal rays which had electrical and magnetic properties opposite of an electron. Definition of a canal rays is that the positively charged radiation produced in the discharged tube at low pressure and high voltage are called canal rays. Canal rays are the positively charged rays. Rutherford experiment, which is very important in that, is Rutherford took a thin gold foil and made alpha particles helium, positively charged helium ions, to fall on it. He selected a gold foil because he wanted as thin layer as possible. This gold foil was about 1000 atoms thick. Alpha particles are double charged helium ions. Since they have a mass of 4U, the fast moving alpha particle have high amount of energy. What were the observations? Most of the alpha particle passed through the gold foil without getting deflected. Most of the fast moving alpha particle passed through the gold foil. Surprisingly, 1 out of every 12,000 particles appeared to rebound. Most of the space inside the atom is empty because most of the alpha particles pass through the gold foil without getting deflected. This means that the alpha particles are negatively charged. As we know, the negative charge and positive charge always get attracted. So this is saying that many of the alpha particles move straight, and these are the negative charge. So inside in the atom, there is a positive charge which is actually attracting the negative charge. That's why the negative charge is passing from the gold foil. Very few particles were deflected from their path, indicating that the positive charge of the atom occupies very little space. The radius of the nucleus is about 10 raised to the power 5 times less than the radius of an atom. Conclusions. This is a positively charged center in an atom called the nucleus. The mass of an atom resides in the nucleus. The electrons revolve around the nucleus in a circular path, and the size of a nucleus is very small as compared to the size of an atom. What were the drawbacks? Rutherford's model was failed by the branch of a physics that was quantum mechanics. According to the branch, when a charged particle revolves around a fixed target continuously, it loses its energy. In Rutherford atomic model, nucleus and electrons are held together by electrostatic force of attraction, which would lead to the fusion between them. But this does not happen in an atom. This was a model of Rutherford. So this is a gold foil. This screen is of zinc sulfide, and these are the alpha particles. So we can see some of the alpha particles deflected, and mostly the alpha particles move straight when bombarded on a gold foil. Now comes James Chadwick. In 1932, James Chadwick proved that the atomic nucleus contained a neutral particle which had been proposed more than a decade earlier by Rutherford, officially discovered the nucleus. A neutron is a subatomic particle contained in an atomic nucleus. It has no net electric charge. It means we can see the charge of a proton is positive and the charge of an electron is negative. That's why negative and positive they makes the neutron neutral. That's why it is having no charge. Subatomic particles is electron, proton, and neutron. The symbol is capital E, capital P, and small n. The location of an electron in an atom is around the nucleus, means in the orbits, and protons and neutrons are present in an atom in the nucleus, and they both make the nucleons. Charge of an electron is -1, charge of a proton is +1, and charge of a neutron is 0. Relative mass of electron is 1 divided by 1840. Proton 1 and neutron again 1. Atomic number of an element is defined as the number of unit positive charges on the nucleus of an atom of that element, or as the number of protons present in the nucleus. Simply we can say atomic number is equals to number of the protons in the nucleus. Atomic number is represented by Z. Number of electrons is also equals to number of protons. So for an example, hydrogen is there. The atomic number is 1. So it will having be 1 proton. Helium atomic number is 2. So there are 2 protons in it. How to find out the neutrons? That is mass number minus atomic number. So actually mass number is defined as the sum of the number of protons and neutrons present in the nucleus of an atom. Mass number is mass of protons or number of protons plus number of neutrons. Like carbon, the mass number is 12. So 6 protons, 6 neutron mass makes 12U. Aluminium mass number 27, 13 protons, 14 neutrons, mass 27U. Now this is how a symbol is represented. Let's take this is He, that is the elemental symbol of helium. This 2 is the atomic number or proton number that is represented by Z. This 4.003 is atomic mass in AMU. Same here the carbon, the 6 is the atomic number and 12 is the mass number. Mass number, or you can say atomic mass. Okay. Now here comes a question. The mass number of an element is 18. It contains 7 electrons. What is the number of protons and neutrons in it? So first of all, we are given with mass number equals to 18 and electrons equals to 7. So we know electrons is equals to protons. So from this we can identify that in this element there are 7 protons. Now we are given with mass number, protons, and we need to identify the neutrons because mass number is equals to protons plus neutrons. So with the transfer method, we are given with mass number 18. We identified 7 as protons plus neutrons. So we will transfer 7 here. 18 minus 7, that is 11. So 11 neutrons and 7 protons will be there in that element. So now very important thing comes, composition of the atoms of the first 18th elements. So in this table, the name of an element is there, symbol is there, atomic number, number of protons, number of neutrons, number of electrons, distribution of electrons, also known as electronic configuration, and valency. So now how to identify this? Very important thing. Like for an example, let's take very simple element, that is lithium. Okay, so the atomic number is actually 3. Atomic number is 3. So now how to do the electronic configuration? So first of all, let's take the shell K, L, M and N. So let's take these shell. So this is said that in that first cell, like in this shell, 2 electrons should be there. Okay, in this shell 2 electrons should be there. Okay, so फर्स्ट शेल में मैक्सिमम 2 इलेक्ट्रॉन्स होने चाहिए, सेकेंड शेल में 8 इलेक्ट्रॉन्स होने चाहिए, दैन नेक्स्ट शेल में 8 होने चाहिए. तो पहले शेल में जैसे अपन को पता है कि अब लिथियम है और हमें पता है कि ऑलवेज द वैलेंसी इज आइडेंटिफाइड बाय द एटॉमिक नंबर. तो एटॉमिक नंबर ऑफ लिथियम इज एक्चुअली 3. एटॉमिक नंबर ऑफ लिथियम इज एक्चुअली 3. तो मतलब उसमें 3 इलेक्ट्रॉन्स है. तो पहले शेल में तो 2 इलेक्ट्रॉन्स चले गए, अब दूसरे शेल में 1 इलेक्ट्रॉन आना चाहिए. It is easier to remove 1 electron rather than adding 7 electrons in an atom. That's why इसका जो इलेक्ट्रॉनिक कॉन्फ़िगरेशन बनेगा that will be like 2,1 but the valency will be 1. Okay, we can identify the 2,1 but the valency is 1. Same if we take another example like aluminium. Let's take aluminium. The atomic number is 13. So as we know, L, K, L, M and N shells again we will make. First shell there will be 2 electrons. Second shell there will be 8 electrons. So total we are done with 10 electrons. Now 3 electrons are still remaining. So in the M shell we will put 3 electrons. But it is easier to remove 3 electrons rather than adding 5 electrons in it, because in the last shell maximum we know 8 electrons should be there. So it is easier to remove 3 electrons rather than adding 5 electrons. That's why the electronic configuration will be like 2, 8, 3 and the valency will be 3. We can see here the 2, 8, 3 is the electronic configuration and the valency is 3. I hope this is clear to all of you. Let's start that a maximum number of electrons that can be filled in the outermost orbit is 8. An outermost shell which had 8 electrons was said to possess an octet. Means outermost shell में 8 इलेक्ट्रॉन होने चाहिए और उसको हम ऑक्टेट भी कहते हैं. Now what is the definition of a valency? The combining capacity of an atoms of element, that is their tendency to react and form molecules with atoms of the same or different elements, is called valency. Valency is always calculated from the atomic number of an element. Isotopes, elements which have same atomic number but different atomic masses. So there are 3 types of isotopes of hydrogen and 3 isotopes of carbon. Like we can see here in the carbon, the atomic number is 6, 6 and 6, but the atomic masses is 12, 13 and 14. So this is how the atomic mass is different but the atomic number is same. So some of the applications of isotopes are like an isotope of uranium is used as a fuel in nuclear reactors. An isotope of cobalt is used in the treatment of cancer. Also the isotope of iodine is used in the treatment of goiter. Now here a question arises. Chlorine occurs in the nature of 2 isotopic forms with masses 35U and 37U. And the ratio of the chlorine is 3:1. So we can't take once 35U and then 37U. We need to take an average atomic mass. So how to calculate it? That is 35 multiplied by 75 upon 100 plus 35 multiplied by 25 upon 100. 75 of 35 comes from this ratio, that 3:1. So when we will solve it, it will be 35 multiplied by 3 upon 4 plus 37 multiplied by 1 upon 4. That will be 105 upon 4 plus 37 upon 4. And when we will join them, it will be 142 upon 4. And when we will divide this number 142 divided by 4, it will come 35.5 U. And we can see that the chlorine is having the atomic mass as 35.5 U. Isobars, elements which have different atomic number but have same mass number. ऐसे एलिमेंट्स जिनके एटॉमिक नंबर तो डिफरेंट होते हैं बट एटॉमिक मासेस सेम होते हैं, उनको हम आइसोबार्स कहते हैं. सो लाइक अ न्यू क्वेश्चन अराइजेस हियर. An atom contains 3 protons, 3 electrons and 4 neutrons. What is the atomic number, mass number and valency? So we know that we are given with protons, neutrons and electrons. Protons is equals to 3, electrons is 3, neutrons is 4. And we know we need to identify the atomic number, that is that number of protons is equals to number of atomic number. So protons is 3, that's why atomic number is also 3. Mass number we know with the help of protons and neutrons, that is protons is 3 and neutrons is 4. So 3 plus 4, that is 7. Now how to find the valency? Valency is like, हमें पता है कि वैलेंसी हमेशा एटॉमिक नंबर से निकलती है, दैट इज 3. वी हैव आइडेंटिफाइड दैट द एटॉमिक नंबर इज 3. सो अगर इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन करना हो तो पहले शेल में अपन 2 और दूसरे शेल में अब कितने बचे, बिकॉज 3 इलेक्ट्रॉन्स शुड बी फिल्ड. पहले शेल में तो 2 हो गए, दैट इज मैक्सिमम. दूसरे शेल में 1 होना चाहिए. तो इलेक्ट्रॉनिक कॉन्फ़िगरेशन जो होगी दैट इज 2, 1, बट द वैलेंसी विल बी 1. Because it is easier to remove 1 electron rather than adding 7 electrons in it. That's why the valency is 7. I hope that it is fine. And this element is actually lithium, because we can see the lithium atomic number is 3, mass number is 7, and the valency is 1. I hope this is clear to you all. Thank you for listening this patiently, and I hope you like my video. For more such videos, please like, share and subscribe my channel. Thank you. Bye-bye.